Advent of Code is a series of programming challenges that are published every December. 2 challenges for every day leading up to Christmas, so 50 challenges in total. And I'm gonna be looking at Advent of Code 2024, Day 1. I'm going in completely blind, I have no idea what awaits me. So it's interesting that on the website here it says that Advent of Code can be solved in any programming language you like. So let's hold them to it, shall we? Funciton is an esoteric programming language that I invented. It consists of lines and boxes. The example shown here is the factorial function. And I'm going to try and solve Advent of Code problems in that language. Now let's step right in. It seems that I can select any day, because obviously the challenge is over. I'm just looking at the archive. But we're gonna start at the top, Day 1. Day 1, Historian Hysteria. Throughout the chief's office, the historically significant locations are listed not by name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into 2 groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the 2 lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number on the left list with the smallest number in the right list, then the second smallest left number with the second I see. Within each pair, figure out how far apart the 2 numbers are. You'll need to add up all of these distances. For example, if you pair up a 3 from the left with a 7 from the right, the distance apart is 4. And if you pair up a 9 with a 3, the distance is 6. In the example list above, the pairs and distances would be as follows. The smallest number is a 1, so that would be this one. And the smallest on the right is a 3. I guess there are multiple occurrences. The distance between them is 2. The second smallest number in the left list is 2, so that would be this one. And the second smallest number in the right list is another 3, okay. That makes sense. The distance between them is 1. And then we keep going, and then the distance is 5. To find the total distance, add up the distances between all of the pairs you found. In the example above, this is all of that, a total distance of 11. Your actual left and right lists contain many location IDs. What is the total distance between your lists? Okay, this is reasonably straightforward, which is of course what I would have expected for the puzzle on the first day. Okay, so it looks like the input is just a list of integers separated with 3 spaces. And then of course there are new lines separating the lines. So I guess what I'm going to do is I'm going to split at the new line first. And then I have a sequence of lines of text. And then I can run that sequence through 2 different mapping functions. The first one is going to extract the first integer and the second one is going to extract the second. And then I'm going to have 2 lazy sequences, and I can zip them. Zipping 2 sequences means that we're going to be pairing them up one at a time, and then we can run some kind of processing on each pair, which in this case we're going to calculate the absolute difference. Oh, no. No, I need to sort them first, so let's extract the integers and then sort each of the 2 lists. And then once we have the sorted lists, then we can zip them. And then after the zipping, I will have a list of all of the absolute differences, and then I can just add them up. Alright, let's get cracking. I'm gonna start writing some code. So the first thing we need to do, of course, is to obtain the standard input, which we do with an empty double-lined box like this. And this will give us a single string, which we need to split at all of the new lines. Now, I have a list of all the library functions that I've already written in Funciton on the esolangs page, which you can see here. And this is where they are all listed. And we're going to need something that can separate a string at every occurrence of a substring. So I'm going to be using this function to split at the new lines. So let's add a call to that function. But we need to pass in both the string from standard input as well as the separator, which is the new line, which by the way is character number 13. So I'm actually going to put this function call over here. And then here on the left, we're going to need the 13, which is the new line. Okay, now I have a lazy sequence of the lines of text. Now I need to run map over this, but I need to do that twice. So the first thing I want to do is take 2 copies of this list, which I can do by just using a splitter like this. But I can already see that geometrically I want the map function to be like okay, so let's copy this box and then you'll see what I mean. So if I put that box here, right, and then there you go. So now I can put the lambda expression on the left-hand side, which is going to be a bit complicated. Okay, so a lambda expression is going to look like this, well, the thing on the left. So we need 3 double lines, and in counterclockwise order we have lambda input, output 1, output 2. Let's always remember that. So we need a box that looks like this. Okay, so let me move that over to the right a bit. So this is where the lambda comes out. That goes into the map function. So that means that this is the input to the lambda expression. Now I want to split the input at every occurrence of 3 spaces. Now I have a function under string handling which is called the single split function, which I can use to split a string into just 2 substrings, which is exactly what we want. Okay, let's move this over to the right again. Let's put a function call like here roundabout. Now, this function is going to take 2 parameters, the string that we want to split, which is the input to our lambda expression, and the string that we want to split by, which is 3 spaces. So that is going to come in here at the top. But in order to be able to do that, we need to encode a string consisting of 3 spaces as a single integer. So the next thing I need to do is I'll need to write myself some kind of helper which I can use to encode strings. So let's write a little program that will take standard input, and the Funciton interpreter will already convert that input to an integer, but then we need to output that integer in decimal. So we actually need to convert the integer that this is to a string, which we can do with this function. Okay, so I called this program str to int, so I can pass in some string, like let's say the lowercase a, which will hopefully give me 97, because that's the Unicode code value for the lowercase a. But what we want is 1, 2, 3 spaces, and that gives us this number here. Okay, so coming back to the program, we're gonna have to put that number somewhere here. So that's gonna go into the string split function, and now that's gonna return 2 outputs, right? The one on the left and the one on the right. So we're gonna be making 2 separate lambda expressions. So for this one, I'm only interested in the one that comes out here, which is the first output. So that needs to go into this connector on the lambda expression. We don't care about the other one, that the map function doesn't care what the other output returns. So just for the heck of it, why don't I just pass the other one into here and it'll just get ignored. Okay, so now what I'm going to do is I'm going to add a wire crossing function here, so I can cross the 2 wires. Okay, so that was our first lambda expression. Now we need to do the exact same thing again, but this time have the string split function return the other value. So let's just take a copy of this whole thing. So now I want these connections to be different, and all of that needs to go into a second call to the map function. So let's put that here. Okay. So I need to connect this up with this side of the map function. Okay, so the next thing I need to do is I need to sort both of these lists. So let's see if I already have a sorting function, and indeed I do. This one here, and it's called sort ascending. So I'm just going to pass the sequence that comes out of the map into a sort function. And then of course I need to do the exact same thing on the other one. And now this thing needs to escape this confined space. So I'm going to use another wire crossing function. So I'm just going to copy this one here. Okay, and now we have both of those sorted lists. So the next thing I need is the zip function, which is right here. This is a z with a curl. So let's join them all up. Now, one thing that's important to note is that the order of the inputs on the zip function matters, because the one that comes in here is the one that's going to be first. Wait a second, how does the zip function actually process each pair of inputs? I've totally forgotten how it does that, so I'm going to look this up in the library. Okay, let's zoom out a bit so that the whole thing fits on the screen. Now, there are 2 issues that I just realized. So first of all, the new line character is of course not 13. 13 is the carriage return. So we need to change that to a 10, that's the line feed. The second issue is that the sort function, which I just used, well, let's look it up in the library, and we see it's right here. It's pretty big. But notice especially the comment which says sort by selector. So this function, in fact, you can also tell here that it expects two inputs. One of them is the input sequence, and the other one is the selector, which is a function that will modify every element, and then you sort by the modified element. So we could just pass in the identity function here and just sort by the elements directly like that. But I think it would be useful for the future to have a sort function which literally just sorts integers. So I'm going to write such a sort function, and while I'm at it, then you can understand how the sort function actually works. So here's how the sort function is going to work. First of all, of course, if the input sequence is empty, then we can just return the empty sequence because there's nothing to do. So if it's not empty, then we're going to have a bunch of integers which we want to sort. So let's take a look at the very first integer. And then we're going to go through the list to find all of the elements that are smaller than that integer. We can use the filter function for that. And then we go through the list a second time to find all the elements that are greater than or equal to. And that will give us the entire rest of the list. So now we have all the elements that are smaller than A, but they're still in some kind of random order. So we're going to use a recursive call to sort that list. And then that will come back with a sorted version of that part of the list. And then we need to insert the element that we were originally looking at, the one that was at the start of the list. And then we append the rest of them, except that we need to sort those two. So there is a recursive call there as well. So let's see how we might write that in Funciton. So the first thing we need, of course, is a question mark box, because we need to check if the input is empty, don't we? So the input sequence is going to go here. And if it's empty, then we want to return an empty sequence, which of course we represent by the number 0. Next, what is the final result going to be? It's going to be a concatenation of the left part with the rest of the list. So looking at the library, we have a function here for concatenating two sequences. So we're going to use that function. So let's apply the concatenation function. What do we want to concatenate? Well, the first thing in the concatenation is, of course, the result of the recursive call for the first part of the sequence. So we need the recursive call, so I'm going to insert that right here. And then after that, we need to pass something into this recursive call, and that something is the first part. So we need to find all of the elements that are less than the first element. So this is going to be the result of a filter. So let's think about what we need to filter. Well, the first thing that goes into the filter is, of course, the sequence. But we don't want the whole sequence. We want the sequence with the first element removed, because we're already looking at the first element. So I'm going to call that the tail, because it's going to be the tail of the input sequence. The other thing that needs to go into the filter function is the lambda expression. So we need to create a lambda expression that will check if a number is less than some number which we have yet to discover. In counterclockwise order, we have the lambda expression and then the input and then the two outputs. Now, we don't care about the second output, so we can just put anything there. But we do care about the first input, and we need that to be something less than something. So let's put a less than call there. All right, and since we don't care about the other element here, I'm going to put a 0 there. Now we might be tempted to connect the head and tail and actually calculate the head and the tail, but we're actually going to need the head and tail again, because we need to also create the list of things that are greater or equal to the head. So I'm going to do that first. Now, the thing that comes after the concatenation is going to be the rest of the list that we want, which consists of the element we're looking at, which is the head, and the rest of the list of elements that is greater or equal to the head. So this means that we will need to add the head element to the start of the result of the second recursive call. And the way that we do that is by declaring a lambda expression, because remember, every lazy sequence is actually a lambda expression that returns its first element and the rest of the sequence, so head and tail. So I'm going to copy the lambda expression box here. I'm going to put that here, and I'm probably going to run out of space now. So this is the lambda expression, and this is the input. The input to the lambda expression for a lazy sequence doesn't matter. So I'm going to silence this input. And then we want the first output to be the head, because that's the element that we want to add to the front. And then the second output, which is this one here, is going to be the result of the second recursive call. What goes into that is going to be another filter function that is very much like this one here. So I'm just going to copy this. Now the first input to the filter function is still the tail, just as before. but the other end here is going to be a lambda expression that does the greater or equal to head thing. So I'm actually going to use a wire crossing function right here so that I can punch through this wire. And then we're going to put the lambda expression right here. So again, we have lambda expression and then input. And the input is the thing that we need to compare. So that's where the greater or equal to will go. And then we have output 1 and output 2. And output 2 is the one that we don't care about. So I'm just going to put a 0 there. Okay, so we need a comparison. And we want the input to the lambda expression, which is here. So I'm just going to connect that to be greater or equal to the head. So we need the head here. Okay, so now we can see that there are 3 uses of head and 2 uses of tail. Let's scroll up a bit again. Now, how do we obtain the head and the tail? Well, remember that the sequence is going to be a lambda expression, so we need to call that lambda expression. And the first result from the lambda expression is going to be the head, and the second output is going to be the tail. So let me just draw a lambda expression call node, and now let's connect up these multiple occurrences of head. Now the tail, of course, is kind of trapped in here, so we're going to need to punch through this. So I'm going to use the wire crossing function, which is right here. And let's not forget to connect that up with the other tail, which is over here. Now the head and the tail are going to come out of this lambda expression in counterclockwise order. So I guess I can just put the lambda expression literally right here, and then the tail will come out the bottom. All right, so this is our output 1, output 2. So this is where the sequence goes in, and we don't care what we pass into it, so the input doesn't matter, so I'm just going to pass in a 0. And now all that's left to do is to connect up the 2 occurrences of the sequence. Okay, it looks like we've created a sort function, but I shouldn't trust myself that this is flawless on the first try. So I think we should test this. And the way I'm going to test it is I'm going to write a quick program which can just take a list of numbers as input and it will sort them. So what we have here is something that takes standard input and then it will split the standard input at all the occurrences of this character, which is the space. So we end up with strings from the input separated by spaces. So we need to convert those strings to integers. So let's use a map function for that. So the first argument to the map function is of course the sequence that we just created. And the second one, which we need to put down here, is going to be the lambda expression that maps every element. Okay, if that's the lambda expression, then this is the input to the lambda. And we want to convert from strings to integers. So let's put that function right here. And that needs to go into the output to the lambda expression. And we don't care about the other output because the map function doesn't use it. So I'm just going to put 0 in there. So now we have a list of integers and now we want to sort them. So I need to pass this, the result of the map, I need to pass that through the sort function that we just wrote. And then after we're done with that, I now need to map it back to strings for output. And then we're going to go the opposite way. So we're going to convert, and as I write this, it occurs to me that I actually put the wrong one here. We wanted to convert from strings to integers. So I actually need to change this one. And this is the one that turns the integers back into strings. And now, instead of sorting that again, we want to output the whole thing as a single string, which we do by joining it with a separator. And the separator, I'm just going to use the comma, which is character number 44. This is the sequence and this is the separator, so we need the output to go up. Okay, if I haven't made a mistake, then hopefully this will work. So let's run our test program that we just wrote with an input string of, I don't know, 1, 2, 3. That's already sorted. So just, oh yeah, of course, I declared the function in the source file for our Advent of Code program. I need to put it inside the library, so I'm going to move that. And then let's run this again. And I get 1, 2, 3. So now let's put some random numbers here. And let's see. Wow, it worked. First try. Not bad, huh? Now, since this is going to be in the library, I want to quickly write a comment for this. I think I'm going to put that on top. There you go. That looks nice. Okay, cool. Now back to Advent of Code. We had this program and we need to replace this with a new function that we wrote, the one that can just sort integers. And as I look at this program, I realize there's another thing that we forgot. So we're taking our standard input and we're splitting it at the new lines, so that will still be strings. And inside the lambda for the map function, we're just splitting that string into 2 more strings. But what we actually want here is we want the integer values, right? Because our input file is going to contain the values in decimal using ASCII characters. And we want to turn those into integers. So we need to actually put a function call here. Okay, and we need that to be the... Hang on, we want to convert integers. Yeah, it's the other way around. But then, of course, we need to do the same thing down here as well. No, wrong. This is the wrong wire. We need to put it on this wire. Okay, so now if we haven't made a mistake, then what comes out of here is going to be the sorted list on the left, the left list. And here we have the sorted version of the right list. And we're passing that into the zip function. Now, I think I may be misremembering how the zip function works, because I think that it actually takes a lambda expression as well. So let's quickly take a look at that. So we can see here that it actually expects 3 inputs. And I assume, look at how many lambda expressions there are here. So it stands to reason that we want a lambda expression that takes 2 arguments. In other words, a lambda expression inside of a lambda expression. So this won't work. We need the... Okay, so this is going to be the first input. This is going to be the second input. And by input, I mean sequence. And then what we put here is going to be the lambda expression. So we're going to have to put another lambda expression there. And then, of course, because we need that lambda expression to be able to take 2 arguments or 2 parameters, we're going to nest 2 of them inside of each other. So this is going to be integer 1 and this is going to be integer 2. And then this is going to be the output. And then these are the secondary outputs for both of those, which the zip function doesn't care about. Now, what do we need to do with these integers? Well, let's take another look at this. What we actually need to do is we need to find how far apart the 2 numbers are. So that's another way of saying the absolute difference. So what I'm going to do is I'm going to subtract the 2 values. And then I'm going to use the absolute value function. So this should calculate the differences that we want. So what comes out of the zip function is a sequence of all of those differences. But what we actually want is we want to add them all up. All of those distances is what they call them. So we're going to just pass that right into the sum function, which looks like this. And then we get an integer out, which we need to turn into a string. So I'm going to put another function here, and I'm going to do this. Okay, and then let's try this. Let's run this. Now I want to try this with a simple input first. So let's try something where there is only 1 line. So if I put 1, 3 spaces and a 1, the difference should be 0. So let's run that. So this is 1a, and we want to pass in 1a.txt. Program is ambiguous. Well, that is definitely a bummer. Okay, funny story. So I just ran this program and I'm getting this error message. And initially I didn't know what was going on, so I stopped the video recording in order to examine this. I checked if there is a bug in the Funciton program that we just wrote. Turns out there isn't. And then I checked if there is a bug in the interpreter, because maybe that error message is erroneous. Well, that is not the case either. It turns out this error message is actually the result of something really rather subtle, and the details of this are kind of outside the scope of this video. But we can work around the problem. So I'm going to put a 0 here, which I'm going to put into that second output of the lambda expression. And then this second output of the string split function, well, I'm just going to use our sort of loopy construct to silence that. Now, if I run this, I'm getting a 0. So now I'm going to take the input file that is provided by the puzzle, and I'm going to paste that into this file. I'm going to make sure that there is no extraneous new line at the end, and I'm also going to make sure that this is in Unix format so that I don't get an extra carriage return for every new line. And then I'm going to run that program. And I fully expect that this is going to take a while because the input file is pretty large, it's 1,000 lines. So it's going to take a while to process. And it turns out that the answer is... So going back to the puzzle page in the Advent of Code website, we can scroll down to the bottom. And I'm going to submit that answer. Let's see what it says. That's the right answer. You are 1 gold star closer to finding the chief historian. Okay, so we've solved the first part of the first day. So I'm going to continue to part 2, and then I'm going to see you in the next video.